Example 4 in the book, we are going to skip. We're going to omit. It's kind of cool, but it's a little bit complicated, and you won't be tested on that. So you can read through it if you'd like, but you can write a little skip beside it. If you turn the page, though, to page 144, you have a whole column there of empty space, and we are going to add our own example 4. Which will look like this. Solve for x. And I made a good one. Square root of x plus 3 equals square root of x minus 5 plus 2. I'll rewrite. First thing is to isolate. With isolating, some of the notes we've had so far, mixed radicals are okay when you isolate. We've also talked about combining like terms when isolating. And thirdly now, with more than one radical, and that means you can't combine them as like terms, we're going to isolate one of them, square, and then we may have to do it again. Do the whole process again. So this is adding something we've seen more than one radical. Last time we had more than one radical in example 3. When we squared both sides, all the radicals went away. This time, when we isolate one radical and we square both sides, we won't get rid of all the radicals right away. And we might have to do this process again. And you keep doing this process of isolating, then squaring over and over again until you have no radicals left. Right, 3 was solve for x, and then 4 was to verify. So there's our steps again. Isolate. And the isolate thing adds layers of complexity as we've gone to different kinds of questions. But for this one, we have 2 square roots. These square roots are not like radicals. So if we tried to combine them, we wouldn't be able to. So then what we do is, with more than one radical, isolate one of them. Can you see that the square root of x plus 3 is already isolated? It's already by itself on one side. So then what we're going to do is we're going to square it and see what happens. Where this gets complicated is on the right side. The left side, easy peasy. Square that. You're just going to get x plus 3. I don't even need brackets around it. The right side, though, when you square that, you're going to be tempted just to square the first one and just square the last one. But squaring means multiply by itself. So if I actually wrote it out as multiplying by itself, you might recognize this is a different kind of multiplication. How do you do those kind of multiplications? You're going to have to FOIL. So you're kind of like, oh my goodness, this is getting bigger and more complicated seeming than I thought. Am I doing the right thing? And sometimes when things get more complicated and bigger, you just stop, right? You're just like, okay, yuck. Go to the next question, leave it blank on a test or quiz. Okay? In this case, it's okay to get a little messy. When I multiply this out, sure enough, this times this, well, square root times the square root times by itself, the square root will go away. That'll just be x minus 5. So that's good. Yeah. It's not a conjugate, right? Because you're thinking this second one to be a minus here. In here? like this, this, and this, they would both be minus because what squaring means is take exactly what you have and multiply it by itself. So it stays identical to what we had before. Yeah. But we saw with the conjugate, right, when we were rationalizing a denominator, sometimes we change the negative to a positive. So it's good to see those things and make sure you know what are the different things and what are the different questions that have that. So the first ones, root x minus 5 times root x minus 5, the square roots will cancel out. Then I have root x minus 5 times 2, which, multiplying radicals, you'd multiply the coefficients and multiply the radicals, will just leave me with 2x minus 5. I have another 2x minus 5, and then plus 4. Got a little messy, right? Too messy. So we started with 2 radicals. I've now FOILed, and I still have 2 radicals, but can you see that this time the 2 radicals are like radicals? So they can be combined, and I can go through the process of one again of isolating. Just simplifying the right side a little bit. Can you see that the minus 5 and the 4 can be put together? And I'll get x minus 1, and the 2 root x minus 5 and the other 2x minus 5 can get combined and get 4 root x minus 5. I've got a single radical now. I started with 2. Now I'm down to 1. So now we can isolate again. So I'm going to move the x over on both sides. I'm going to move the 1 over on both sides. And I'm going to get just 4 equal to 4 root x minus 5. You could square both sides right now. You could also divide by 4 on both sides right now. Can you see that dividing by 4 wouldn't give us a fraction? It'll work out nicely. If I divide both sides by 4, I'll just get this, which is not bad. And now we've isolated the radical again. We can go to step 2, square both sides. 1 squared is 1. And now you solve. Finally, we're going to verify. Left side, right side. Our original question, left side was root x plus 3. Right side was x minus 5 plus 1 plus 2. So plug in 6. 6 plus 3 is 9. Square root of 9 is 3. Plug in 6. 6 minus 5 plus 2. Square root of 1 is 1. Plus 2 is 3. And it works. Wouldn't it be nasty if we had done all that work and then find out it was, I mean, an extraneous root?